In this video, we are going to continue with our review of the 5th grade curriculum, and we are now on part 3. My dog Jack and I will now take you through the next part of our list. So folks, in our previous video, part 2, we ended up about right here, multiplying two decimals. So now we're on division by decimals. So we're going to divide decimals by power of 10. Let's see where that takes us. Okay, when we divide by powers of 10, we're talking about dividing numbers by 10, 100, and 1,000. That's what powers of 10 mean. For example, if you have 10 to the first power, that means you have 10 all by its lonesome. If you have 10 to the second power, that would be 10 times itself listed twice. And we know that 10 times 10 equals 100. Here, we would have 10 to the third power. So that would be 10 times itself 3 times. So 10 times 10 would be 100, and then 100 times 10 would be 1,000. So that's what we mean by powers of 10. So in this section of the video, we are going to be dividing by 10, 100, and 1,000. And specifically, we're going to be dividing decimal numbers. Okay, before we get into division, let's briefly remind ourselves about multiplication of decimals. Okay, this is a quick review that we covered in our last video. So if we have the number 9.27 and we're going to multiply by 10, we know that number is going to get bigger. When you multiply a number by 10, it's going to get bigger. How much bigger? It's going to get bigger by 1 decimal place. How do we know it's 1 decimal place? Because there's 1 0. So we're going to take this decimal and we're going to move it 1 place to the right, and we're going to end up with 92.7. Okay, so we took this decimal place, we moved it 1 place over, and we get a larger number. Multiplication, you get larger. So now, if we divide by 10, what do you think is going to happen? If you divide a number by 10, it's going to get smaller. So how do we make a number smaller? We move the decimal place to the left. How many places do we move it to the left? The number of zeros takes us. So if we're going to divide 9.27 by 10, we're going to take the original decimal place and we're going to move it 1 place to the left, and our final answer is going to be 0.927, otherwise known as 927 thousandths. 9.27 goes to 927 thousandths. We get smaller because we are dividing. Folks, that's it in a nutshell. Let's do some examples to reinforce this concept. If I have 90 divided by 10, we know that the 90 has a hidden decimal place right there. We're dividing, therefore we're going to get smaller, therefore we're going to move to the left 1 place. Why are we going to move 1 place? Because there's only 1 0, and the result is going to be 9. If you want, you can put the 0 there. You don't have to. 90 getting smaller by 1 decimal place, 9.0. Let's try another one. How about 6,381 divided by 10? We're going to get smaller. The original decimal place is at the end. We move it 1 place to the left. Becomes 638.1. Okay. How would you handle this one? Okay, what I would say to myself is, the original decimal point is here. We are dividing. We know we're going to get smaller. We know we're going to move the decimal place to the left. Make this original 829 become smaller. How many places are we going to go to the left? 2. How do we know it's 2 places? Because there's 2 zeros. So we're going to go 1, 2, and we're going to end up right there, and we're going to get 8.29. Folks, what would we get? I'll throw a curveball at you. If we have 829 times 100, how would you handle that? Well, we'd have the original decimal place. We see that it's now multiplication. We now know that the original number, which is 829, is going to get bigger by 2 zeros. So let's come down here and make this bigger by 2 zeros since we're multiplying. So we're going to move the decimal place to the right 2 zeros, but we are not going to move into blank space like this because it's too confusing. So what do? We put some placeholder zeros. Now we move 2 places to the right. Now we know where we're going. Final answer. $82,900. So we went from 829 multiplying by 100 to a bigger number. Up here, we went from 829 dividing by 100. We get a smaller number. Now, don't forget, folks, that a fraction is another way you will see division. In other words, sometimes you'll be presented with this problem like so, with that division symbol, and other times you'll see it as a fraction. Okay, don't let that confuse you. This fraction form is the same thing as this division problem. 2,456 divided by 10. This division sign, ladies and gentlemen, this fraction line can be thought of as a division sign. Look, it even has a fraction line within it. Okay, look. Okay, so division, look, even if you look at the division sign, you see a numerator and a denominator here. I never noticed that before. Okay, so right there, look at that. That division symbol looks just like a fraction with a numerator on the top, denominator on the bottom. So there we go. So we are dividing. When you have 256 over 10, this is division. How do we handle that? Well, here's our original decimal place. We are in division mode. We're going to get smaller. When we get smaller, we go to the left. So that 2456 becomes 245.6. Let's do a couple more, and then we'll move on. How about this is a hard one. 32.943. That would be read as 32 and 943 thousandths. Remember, tenths, hundredths, thousandths. Okay, and this has nothing to do with the fact that thousand is in the denominator. So this problem is 32 and 943 thousandths divided by 1,000. So this is going to get smaller. How much smaller is that numerator going to get? 3 decimal places. How do I know 3 decimal places? Because there's 3 zeros in 1,000. So if we're going to make this number, 32.943, smaller, we have to move this way. Now, just looking at this, if I'm going to move 3 decimal places to the left, 1, 2, I'm into Never Never Land. I'm into blank space. So what I'm going to do here is I'm going to put placeholder zeros. I don't like moving the decimal place into outer space. Okay, so now we're going to take this decimal place. Since we're dividing, remember the division symbol has a fraction line. We're dividing. We're going to get smaller. We're going to go this way. 1, 2, 3. Our final answer, 0.0329943. Smaller. Division. Okay, I think you folks got it. Let's move on to the next list. Let's see what we have here. Divide 4-digit numbers by 2-digit numbers. Okay, this is not hard, but there's a lot of busy work. Okay, so we're going to divide a 4-digit number by a 2-digit number. Again, you might see this same problem like this. Okay. If you see a fraction like this and you're asked to do division, how do we handle that, folks? We build a box. And we drop the numerator right into the box. So there's our problem right there. Okay, so let's clean this up a little bit, and I'm going to show you how to do these. Okay, this is how you do these. Let's make that box a little neater. Let's bring the 16 over. I should have just erased and started over. Sorry about this delay, folks. Okay, so how do we do this? Well, we ask ourselves, how many times does 16 go into 3? We can't do it. How many times does 16 go into 34? Well, I happen to know it's 2, but it may be harder than that. It may be something like, how many times does 16 go into 79? Okay, we don't know things like that off the top of our head. So this is what you do. You build a table. Okay, so let's move this over here temporarily. And we're going to build a table involving 16, specifically the multiples of 16. So we know that 1 times 16 equals 16, 2 times 16 equals 32, 3 times 16 is going to equal, 3 times 6 is 18, carry the 1, 48. Okay, so we are building a table of multiples. Remember, multiples are when you take a number in a box and you get bigger. Remember the section a few videos ago on multiples? Okay, so if you put 16 in the box, the factors would be on this side, 1 and 16, 2 and 8, and then 4 times 4, those would be the factors, but the multiples are over here. 1 times 16 equals 16, 2 times 16 equals 32, 3 times 16 equals 48, and then at this point, if we want, we can either continue with the multiplication or we can keep adding 16. 2 ways to get multiples, okay? Sorry, 64. Okay, so let's continue making the multiples of 16, and now I'm going to show you how they play a role in our division problem. Okay, I happen to have them listed here just for the sake of time, but you would be charged with going ahead and completing all these different multiplication steps. And that's good practice. running out of room here, sorry. Okay, so all the information we need to complete this problem is now in green. Okay, let me show you how this works. Okay, so now we go back to our problem and we say to ourselves, okay, 16 can't go into 3. How many times does 16 go into 34? Well, now we go to our table. Here we go. 2 times 16 is 32. We want to get as close to 34 as we can without going over, and here we go. Bring down the 0. How many 16s can go into 20? The answer is 1. 1 times 16 is 16. Bring down the 8. How many 16s go into 48? Here it is right here. 3 times 16 is 48. There's your final answer with no remainder. Let's do another one. How would you handle this problem? Remember, a fraction is a division problem. It's another way to say that. Okay. How do we handle division problems of fractions? We build a box and we drop the numerator into the box. Okay. I learned my lesson. This time I'm just going to rewrite it. Okay, so we're going to take 13. I'm going to divide that into 1, 1, 7, 6. Okay, let's get rid of this. Let's talk about how we would do this. How many 13s go into 1? Can't do it. How many 13s go into 11? Can't do it. How many times does 13 go into 117? Who knows? Nobody that I know knows that off the top of their head. So what do we need to do, folks? We need to build a table of multiples of 13. Once we get our table, we can handle anything that division problem is going to throw at us. Remember, with multiples, we get bigger. 1 times 13 is 13. 2 times 13. Let's do that on the side. 2 times 3 is 6. 2 times 1 is 2. Okay. Folks, when you're building in multiples, you have two choices. You can either go to 3 times 13 and do that on the side, just like we did 2 times 13, or you can add 13 to the previous number. Let's do that. 39. 4 times 13 is going to be 39 plus 13, and that is going to be 52. Okay. Okay. 5 times 13. Let's change gears and do multiplication for that one. 5 times 3 is 15, carry the 1. 5 times 1 is 5, plus 1 is 6, 65. Okay, let's keep going. I know this is an arduous, laborious task, but it's worth it. Okay, let's add 13 here. It becomes 78. 7 times 13. I'm going to go to my list now just to save time. 8 times 13 is 104. 9 times 13 equals 117. Okay. We only need to go up to 9 when you do this table, okay? Because that's what we're going to do. But I can't resist this temptation. If we were to do 10 times 13, what would that be, folks? Well, we're multiplying 13 times 10. 13 has a decimal place here. When we multiply a power of 10 times a number, it's going to get bigger. What we're going to do is we are going to move the decimal place to the right. Okay, here's the original decimal place. We're going to go to the right because we know the final number is going to be bigger. As we move the decimal place to the right, we're into Never Never Land here. See that, all that blank space? So what do? We put placeholder zeros. So now we're going to move this decimal place one place to the right because we're multiplying. We want to get bigger. How do we know we go one decimal place? Because there's 1 0, and we end up at 130. Okay, so 10 times 13 is 130. But we will not need that up here because you only need to go up to 9 when you do long division. Okay, so here we go. How many times does 13 go into 117? We go to our table. And what do you notice right there? 9 times 13 is 117. 9 up here. 9 times 13 is going to give us 117. When we subtract, we're going to get 0. We're going to bring down the 6. How many times does 13 go into 6? 0. 0 times 13 is 0. Remainder 6. So this final answer is going to be 90 and 6/13. Okay. You have to build a table. Okay, folks, let's move on. And let's see what our list says. Okay, now we're going to go to exponents. Okay, what is an exponent? I've alluded to it a little bit when we talked about prime factorization. Do you remember prime factorization, PF? When we had a number like 18, and that becomes 2 times 9, and 3 times 3. So the prime numbers, so we could stop. This becomes 2 times 3 times 3. And then we talked about rewriting this over here as 2 times 3 to the second power, also known as 2 times 3 squared. So 3 squared, or 3 to the second power, means 3 times itself twice. Okay, so that was our brief introduction to exponents, and I mentioned that we would dive a little bit deeper into them, so let's do that. So we already know that 3 to the second power means 3 times itself twice. So if we were to evaluate this, 3 times 3 would be 9. Okay, you might see that word, evaluate. Okay, evaluate just means figure out what this is. So if I asked you to evaluate 2 plus 3, that would be 5. If I asked you to evaluate 2 times 4, that would be 8. So if you're asked to evaluate 2 raised to the third power, that would be 2 times 2 times 2. This 3 is the exponent. Let me write that down. Okay, that's the exponent. This 2 is going to be multiplied by itself 3 times. So if you were to evaluate this, which means figure out what it means, it would be 2 times 2 is 4, times 2 equals 8. Okay. 2 raised to the third power and 8 are equivalent values. Just like 2 times 4 is 8, these are equivalent. They look different, but they have the same value. Look, 2 plus 3 looks different than 5, but they have the same value. How do we know? Because there's an equal sign. Okay. Let's do a couple more, and then we'll move on, because I think you got this. What is 1 to the 4th power? This is tricky. Okay, that would be 1 times itself 4 times. 1 times 1 is 1. 1 times 1 again is 1. 1 times 1 again is 1. You get 1. What would this be, folks? 1 to the 3rd power. It would be 1 times itself 3 times. 1. So what do we learn from this little exercise? When you take 1 and raise it to an exponent, it evaluates to 1 no matter what it is. You could raise 1 to a power of 197.8. Actually, no, you can't do that. Leave out the 0.8. So we can have 1 here 197 times, and you're always going to get 1. One more, and we'll move on. What is 4 raised to the 3rd power? What that means is you take this number and you multiply it by itself however number of times this exponent tells you to. You take this number, you put it right over here, you multiply it by itself however many times you raise to that power. Okay, so if you're asked to evaluate that, it becomes 4 times 4 is 16. 16 times 4, let's do that on the side. 4 times 6 is 24. Carry the 2. 4 times 1 is 4, plus 2 is 6, 64.